All right, on today's episode of Python Papi, we're back inside our TensorFlow course and we're still doing our human emotions detection module. Let's have a look at what we went over today. And today we went over our metrics and we're going to start with some light reading and then we're going to go over some examples. So with that done, let's move on to the metrics of our model. This is how we would define our metrics. Our metric is going to be a categorical accuracy. We will give it a name of accuracy. As you can see here, metrics equals categorical accuracy. The name equals accuracy. We will also have the name of top K category accuracy, which is going to get a value of K equals 2, and then we're going to give that a name of top K accuracy. Now, before we move on, let's explain the top K categorical accuracy metric because we do have two different categorical accuracies. You can see here one is top K and one is regular categorical. So we're going to do the differences right now. We're going to start with these four examples. So you can see here we have three sets of values in each of these examples. P is going to be for predicted. EP is going to be for expected predicted. So this is what the model predicted, and this is what the model was expected to predict. So we have 0, 1, 0, 4, 0, 5. We have 1, 0, 0. And then you can see the rest of the P's and the EPs for every example. Let's go down. So the P columns are what the model predicted, like I said, and the EP columns are what the models were expected to predict. The accuracy rate will be computed as such. Now, taking a look at our first example, we see that the highest value is in our P column is 0.5. You can see here 0.5 or 0.005. That's not the first one. Yeah, 0.5 right here is going to be the highest value in this P column for our first example. And if we look in our EP, the 1 is going to be the highest expected value in that column there. Now, that's going to be incorrect because it doesn't match up. So with the category accuracy, the expected has to be matched with the predicted. So 0.5 is the highest value in the predicted, and 1 is the highest value in the expected, but you can see it in two different locations. So this would be considered incorrect. Now, if we come over here to the second example, we see the 0.8 is the highest value in the predicted, and the 1 is the highest value in the expected predicted. This will also be considered incorrect, as you can see it in two different locations. But for the next two, as you can see, the 0.9 is the highest value in the predicted, and 1 is the highest value in the expected, and in both in the same exact location. So this will be considered correct. Now for the second one or the fourth one here, you see 0.7 is the highest value and 1 is the highest value, and they are in the same position. So that would be considered correct. So that's how we would get that there. And to actually finish calculating that, we would take all of those values and we would draw them out like this. So 0 plus 0 plus 1 will represent everything that we just went over. A 0 for the first two and a 1 for the next two. 1 equals correct, 0 means incorrect. And then we would take the number of correct and divide that by the number of examples. So you have 2 divided by 4, which will give us a 0.5. We multiply that by 100, and that would give us an accuracy rate of 50% for that model. Now for the top K, it's a little bit different. If any of the two highest values in the predicted match the highest value of the EP, we will count that as a correct. So as you can see here, these two highest values are 0.5 and 0.4, but none of them match the highest value of 1, so this will be considered incorrect. But if we look at this one, we have a 0.8 and 0.1 and 0.1. Since these two are the same, we consider that 1 and 2 as the highest values. And this 0.1 here, since it's being the second highest value, and it is correct, we matching with this one here, in this column, it will be considered correct. Same thing with this one. We have 0.9 plus 0.5 and 0.5. You don't have to look at the 0.5 because we see the highest value here matches with the highest value here. That we consider the 1, and the same thing with this one. So this will be a 0, 1, 1, 1 for this prediction. And we'll do the same steps after. So you see here we have 0, 1, 1, 1. You drop the 0 and use the 3 for the 3 correct. This should be a 4 right here, not a 3. So we would do 3 divided by 4 will get us to 0.75 times 100, and that will give us an accuracy rate of 75% for that particular model. Now that's what we did today. We just went over those two concepts for now. Got the math down, and we got to know the differences between the two, how to distinguish them, and then how to actually calculate them all the way out, to find the percentage value of those accuracy models. But yeah. Of course, we're going to keep moving forward, and I will keep you posted every step of the way. But for now, it's the Python Poppy. You guys stay Gucci.